All right, so this lesson will be going through the process of using the derivative of sine and cosine. So when we have the graph of y equals sine, so we have the red line right here, and then we have the graph of y equals cosine. So before I go through and explain it, I'm going to show you visually using Geometr Sketchpad. So right now on my grid, I have the derivative of sine. And as you can see, I have a line that's going to start moving around. So the red line represents the derivative of sine. So it's graphing the value of the tangent at a variety of points. So when I stop that and I look, what do you notice about the graph of the derivative of sine? Hopefully in your brain you're saying, oh my goodness, that's the graph of cosine, because in reality the derivative of sine is cosine. So as you can see, it's exactly cosine, so nothing tricky at all. So the derivative of sine is cosine. If we were to look at the same kind of animation for cosine, so we're starting off with our cosine graph, many of you are probably thinking, oh, it's probably going to be sine. Well, let's see. It's looking pretty close. However, it's not sine itself, but a reflection of sine. So it's been reflected over the y-axis. So that brings us back to talking about the derivative of sine and cosine. So that's what we just looked at. I just thought this joke was very funny. Dad, what's the difference between a sine and a cosine? One is a thing with letters on it, and the other is what you need if your credit's lousy. I'm guessing asking you what a tangent would be would be pointless. It's like an orange, only different. So I just thought that was very amusing. All right, so cool, right? I told you they were cool. The derivative of sine is cosine. The derivative of cosine is negative sine. So you have to remember these. We're not going to go through the derivation the same way that we did with e to the x and b to the x, because the math is a little bit messier. But having said all that, even though it's messy math, it gives us a really cool final product. So as per usual, now we're going to work through a few examples. So as soon as you see a bracket like this, you should immediately be thinking chain rule. So when I do this here, there's only one kind of x, so I don't need to worry about any other rule. As I'm reading left to right, the first thing that I see is sine. So I know the derivative of sine is the cosine of 2x plus 1. So that's my first step. Then I need to take the derivative of 2x plus 1. So y prime of this here is going to be 2, since the derivative of 2x plus 1 is 2, cosine bracket 2x plus 1. When I do this next example, I have two different x's. I have the x and the cosine x. So as soon as there's two different x's, you have to use product rule. So the derivative of the first is 1 times the cosine of x plus the derivative of the second, which is going to be negative sine x times x. So you need to be careful with brackets in this unit. So this becomes the cosine of x minus x sine x. And we can't simplify that anymore. There's no identity or anything that's going to exist here. All right, so now these two, they look very similar. However, they're not. This means the x is squared. So when I do my derivative, I'm going to have the derivative of the cosine is negative sine. The x squared doesn't change. So that's the first part of my derivative. Then I'm multiplying by 2x because that is the derivative of x squared. So I'm going to pull that out in front so I don't run the risk of putting it with my x squared. So that's the derivative of this one. Now this one is not the same thing. Mathematically, that's what this means. It means I have cos squared. So now when I do my derivative, this is a chain rule question. So 2, the exponent comes down, it doesn't change, so I have a 1 here. Then I need to multiply by the derivative of the inside, which in this case is going to be negative sine x. So I get negative 2 cos x sine x. For grade 12, it's okay if you leave it like this, but if you recognize that this is actually the double angle formula, if you don't, that's okay. I would totally accept it, but if you recognize it, then this here is going to be another acceptable answer. Either one of these is fine. All right, so why don't we put E and sine and cosine all in one question to make it that much more fun. So when I do my derivative, y prime equals the derivative of e to the anything is e to the anything. So I'm just rewriting it. Then I'm going to multiply by the derivative of my exponent, which becomes cos x minus sine x. And that's all we can do here. So again, the derivative of e to the anything is itself, and then you have to multiply by the derivative of whatever that exponent is. Yet again, same question. So find the equation of the tangent line at x equals negative pi. So the first thing I'm going to do, I'm going to figure out what f is at negative pi. So I have negative pi squared times the sine of negative 2 pi, which is going to be 0, because the sine of 2 pi is 0. So I have my coordinate. And the fact that y is 0, that'll make things a little bit easier. So now I need my derivative. And it's a product rule. So I have 2x times sine 2x plus x squared times the cos of 2x times 2. Because the derivative of sine is cosine, and then the derivative of 2x is 2. So at this point, I'm going to sub in my negative pi. Sine plus negative pi squared cos of negative 2 pi times 2. So this whole part right here is 0, since the sine of negative 2 pi is 0. So then it's going to be plus 2 pi squared, and the cos of negative 2 pi is 1, so it's just 2 pi squared. So now when I write my equation in the y equals mx plus b format, I have 0 equals negative pi times 2 pi squared plus b. So 2 pi cubed equals b. So my final answer is y equals 2 pi squared x plus 2 pi cubed. And because it's an equation of a line, you wouldn't need to factor it. You could if you wanted to, but you don't need to. So I'm just looking at that quickly. So hopefully there's no algebra mistakes. And that's the end of the sine and cosine lesson.